Algebra 1, Lesson 86, Division of Polynomials. Alright, so pay attention because this can be a tough one. So division of polynomials is talking about problems like this. We have two different polynomials and they want us to divide them. They want us to divide negative 2x plus 5 plus 3x squared by negative 3 plus x. First thing we want to do is we want to rewrite these in descending order. So we're going to set up a division box, and I put a little leg on here so that way I can see this is all the same. And I want to divide this number by this number, and I want to write it in descending order. So I'll start by putting the divisor, which is negative 3 plus x. In descending order, it would be x minus 3, right? So these got to switch places because I want the x first. Now this one in descending order is going to be 3x2, then x, and then 5. So 3x squared minus 2x plus 5. So the descending order is we always want the variable in front, and then we want the highest exponent to the left, right? So this one goes x2, x1, x none, and this one goes x1, x none. All right, once I've got that set up, I'm going to start going through my division algorithm, all right? Now this is where this can get a little bit tricky, all right? So in order to divide, we want to see how many times x can go into 3x squared. Now, the way we're going to do this is we're actually going to set it up as a division problem. So we're only going to check the leading term. We're not going to worry about the negative 3 right now. And the way I can do that is if off to the side, I take this number, 3x squared, and then I divide it by the leading number of x. I simplify that. This will cancel, and that's going to give me 3x. So that's how many times I'm going to put that in there. So up here I'm going to put 3x. Next step I'm going to do is I'm going to multiply, right? So once I've got this top number, which I get through division, I multiply. Now when I multiply, I have to use distributive property. So 3x times x gives me 3x squared. 3x times negative 3 gives me negative 9x. Now, so far the steps of division have not changed. We're just applying rules that we know, like distributive property, multiplication of polynomials, division of polynomials, stuff like that. Now, what gets most people is this very next step, which is we have to subtract, right? Now, what happens when we have to subtract is we have to distribute the subtraction sign. I don't just put minus 3x and then leave it at the first term. I need to distribute this negative over here. So what happens is that 3x squared is going to change to negative 3x squared, and the negative 9x is going to change to positive 9x. So I change both signs when I go to subtract. From there, I then just combine like terms. 3x cancels, so that goes away. Negative 2x plus 9x gives me positive 7x. And then the last step is just the same as normal division. I'm going to bring down the next term. So plus 5 comes down, so now I have 7x plus 5. And then I start the process all over again. So going back to green, I'm going to test 7x over 7. So off to the side, I put 7x over 7, or 7x over x. That divides, and I get 7, right? So the next number I'm going to put up here is going to be plus 7. Then I go into distributive property. I'm going to multiply. 7 times x gives me 7x. 7 times negative 3 gives me negative 21. Now I go to my subtraction step, and then I'm going to change both signs. These cancel. 5 plus 21 gives me 26. All right. Now, when you get to the very end and you have nothing but a whole number, there's nothing else I can bring down. And if I look, there's no way that 26 or x can go into 26. So for this very last term, once I get this whole number at the end, I'm going to bring it up to the top and I'm going to write it as a fraction. So all I do at the very end is I just put plus 26 divided by x minus 3, which is our divisor. And this is my final answer, right? Since there's no way that I can divide 26 by x minus 3, I just write it in the end as a fraction. And that's the answer to my division of polynomials. Now there's one more example you guys need to see. Give me 1 second, I'll put that on. I take it back, I lied. There's actually two examples, but this is the first one. So here we have divide -4 plus x cubed by -3 plus x. Again, I have to put them in descending order. So I'm going to draw my division table. And then I'm going to start by putting this as x minus 3 instead of -3 plus x. Now, this one is tricky. Remember I told you in descending order you have to put x2, x1, x none. Now, if you get a polynomial like this, where there is no x2 and there's no single x term, we have to include them. So I'm going to put the x cubed first, but I'm not going to go straight to -4. I have to include an x2 and an x1 term, but I can't change the number. So the way I do that is I add 0 to the problem. So if I add 0x squared, 0 times x squared is going to be 0. So all I'm doing is adding 0, but I still have an x squared term, which is what I need in order to complete the division. Then I'm going to do the same thing with the x1 term, 0 times x. Right? And then at the very end, then I can put -4. So these ones where you're missing exponents from the highest to the lowest, you add every single exponent, but the ones you're missing, you multiply by 0. So all I'm doing is x cubed plus 0 minus 4. Same number, written differently, so that way I've got every single exponent that I need to divide. From there, I just go back into the steps of division. The first one, I'm going to take x cubed divided by x, that equals x squared. So I put x squared up here. From there I go to multiply through distributive property. X squared times x gives me x cubed. X squared times -3 gives me -3x squared. Then I change the signs. -x, positive 3x squared. These cancel, and I'm left with 3x squared. Then I bring down 0x. And so what we see here is if I don't have these 0x squared and 0x terms, I can't keep dividing, because then I would be stuck over here. I'd have unlike terms. I'd be trying to add -4 and 3x squared, which I can't do. So that's why I add these 0 terms, so I can keep dividing, right? And so then I go back to the first step. I check 3x squared over x equals 3x. So I add positive 3x, and then I multiply again. Positive 3x times x gives me 3x squared. Positive 3x times -3 gives me -9x. From here I subtract. When I subtract, I change both signs. These cancel, and then 0x plus 9x gives me 9x. Now I can bring down the -4. I check again, or I divide. 9x divided by x equals 9. So I put plus 9 up here. 9 times x gives me 9x. 9 times -3 gives me -27. I subtract, changing both signs. The 9x's cancel. -4 plus positive 27 gives me positive 23. And then this last term again, whole number, I cannot divide by x minus 3. So I'm going to take it to the top, and I'll write it as plus 23 divided by x minus 3. And again, I'm at my final answer. All right? So if you're missing exponents, add them by multiplying by 0. Now, the very last example, which I forgot would be in this lesson, is actually much simpler. And it looks like this. Let's say we have 5x cubed minus 9x squared plus x. We have all of that. I'm going to slide down here. Divided by x. So this is the last example. Now you'll notice the difference between this example and the ones above it is this one had a whole number. This one had a whole number, right? So no x and no x. This one, all of the terms have x. We have x cubed, x2, x1. Now this is better because I can divide simply by putting each term over x and then simplifying, right? So the easiest way to divide these, or we could call this factoring, right? So if I divide this by x, what happens here is this number, 5x cubed, becomes 5x squared. Then I copy down the minus. 9x squared, when I divide, just becomes 9x. And then x over x becomes plus 1. And that's my final answer. So division of polynomials can be simple as long as all of your polynomials have an x term. If one of your polynomials is a whole number, like here and here, we have to use this division of polynomials algorithm. So that's it for this lesson. If you have any questions, let me know on Moodle, and I will see you in class.